All right, let's dive right in. We're going to talk about a language that seriously runs just about everything you touch, but you probably never even think about it. Yep, we're talking about C. It's one of the most important programming languages ever.
So let me ask you something. What do your phone, your car, and get this, the Mars rover all have in common? I mean, they're wildly different, right? A phone in your pocket, a car on the road, and a robot on another planet? What's the link?
Well, the answer is C. That's it. The operating system on your phone? C. The control systems in your car? C. The software that's literally navigating a rover millions of miles from here? You guessed it. It's all running on code written in C. It's like this invisible engine that powers our entire modern world.
Okay, so what is C, really? How did this one language become so fundamental to, well, everything? Let's get into it and define what makes C this powerful middle ground.
You gotta go back to the early 70s, to the legendary Bell Labs. C was born there for a super ambitious reason. They needed to build the Unix operating system from scratch. They designed it to be general purpose, which just means it's a flexible tool you can use for all sorts of things. And it's procedural, which is a fancy way of saying it just follows a list of instructions, step by step. So to really get where C fits in, picture a spectrum. On one end, you have high-level languages like Python. They're super human-friendly, easy to read, and they handle a lot of the messy details for you. On the other end, you have low-level stuff like assembly language. That's practically talking directly to the computer's hardware. It's incredibly powerful, but also incredibly complex. And right there in the middle, that's C. It's the perfect bridge. You get the raw, close to the metal power of a low-level language. You can manage memory directly for insane speed, but it's still structured and readable like a high-level one. That control, that's its superpower. And honestly, it's also what makes it a bit tricky. You know, there's this saying that C is the Latin of programming languages, and I just think that is so perfect. Seriously, just like Latin is the root of Spanish, French, and Italian, C is the ancestor of so many languages we use today. Its ideas, its syntax, its core concepts, they are everywhere. When you learn C, you're not just learning one language. You're basically learning the fundamental grammar of how software works. Okay, we've talked about what C is, but how does it actually work? Like, how do you go from a text file full of code to a program that actually does something? Let's look at how we go from code to command. It's a pretty simple idea. It really boils down to 3 simple steps. First, you, the programmer, you just write your instructions in a plain old text file. Step 2, a special program called a compiler takes over. Its job is to translate your human-readable C code into what's called machine code. That's the ones and zeros the computer's processor actually understands. And finally, step 3, the processor runs that machine code, and your program comes to life. So remember that. Write, compile, execute. That's the whole process. And this right here, printf hello world end quote. This is it. This is the starting line for pretty much every C programmer in history. It's the famous Hello World program. All it does is tell the computer to print the words Hello World to the screen. I know, it looks so simple, right? But this one little line is a huge rite of passage. It's the very first hello in a long, powerful conversation with the machine. So you might be thinking, okay, this is all cool history, but why are we still talking about a language from the 70s? I mean, seriously. It's because its legacy isn't just history. It's the world's foundation, even today. Think about this number. 50 plus years. Let that sink in for a second. In the world of tech, where a new framework is hyped up one year and forgotten the next, C has been a dominant critical language for over half a century. That's not just a long time. In tech years, that's an eternity. And there's a really good reason for that longevity. When speed and efficiency are everything, when performance is absolutely non-negotiable, developers still turn to C. We're talking about the very core of operating systems like Windows, Mac OS, and Linux. We're talking about the tiny, efficient code inside your car, your microwave, or a drone. Those are called embedded systems. High-performance video game engines? Yup. Massive databases that power the internet? You bet. They all rely on the raw power of C. But its influence goes even deeper. Look at this family tree. C++, C#, Java, JavaScript, Python. These are some of the most popular languages in the world right now, and they all got their start from C. They inherited its syntax, its structure, its core ideas. It's like C's DNA is just woven into the fabric of modern programming.
So, if there's one thing to take away from all this, it's that C isn't just a programming language. It's more like the bedrock. It's the invisible architecture holding up pretty much every single piece of digital tech you use, every single day. Which leaves us with one final question to chew on. Right now, we've got all these new, easier languages that do a lot of the hard work for us. So why? Why do we keep going back to this language from 1972 for our most important, most critical systems? It really makes you wonder, doesn't it? What does that say about the timeless value of raw power, pure efficiency, and just really good fundamental design? It's something to think about.